Thank you. All right. Hello, is Andrew Losty here, our first speaker? Yes, awesome. Good morning, everyone. I'm Valerie Aurora. I'm one of your two session chairs this morning. Just a reminder to don't forget to rate the talks. There is an email with a link to do that in your inbox. All right, so our first talk, I'm happy to introduce Andrew Losty, a PhD student at University College London, Department of Electronic and Electrical Engineering, to tell you about towards operational and security best practices for DNS in the Internet of Things. Go, Andrew. Thank you.
Good morning, everybody. Thank you very much. I'd like to thank RIPE for the opportunity to present, and I'd like to thank the RIPE community for making such a warm and welcome, inclusive environment. So what I'd like to do is describe some research we've been doing and actions, and a lot of this is going to be driven by there's a wish for engagement. You'll see as to why that comes on a little bit later. So it's not a passive action that I'm trying to accomplish today in terms of saying this is what I've done, end of story, that we're moving on. It's very much an ongoing activity, which I'm hoping that some of you in the room would work with us to participate in. What I've got to do is say that this is a joint action. So we can see the four names there, myself, my supervisor, Anna, Abby, and Matthew, and importantly, Infoblox, Jim Mosley, who's been working with us. So it's very good to have the business side as well as the academic side, and we're working together, and that's been extremely positive. So just a little bit of an overview. We want to give a little bit of a view as to why we're doing this, because it's meaningless if it's just an action. We want to give a review of the current regulations, standards and guidelines. That's not to go over all this again, but it's just to show you as to what we've done and what's driving us in this direction. Then we're going to deal with the lab experimentation that we've been doing and the results. And the final is that where we think this should be going. So we did a paper, and the paper sort of, you've just seen the title, and we did that in collaboration with INRIA, and it was it was accepted at the IETF, so we were very happy about that. And it's to basically carry out empirical research, measurements, observations, experiments, And we did this on 35 current IoT devices to see what is the state of device operations. What are they currently doing? Have they changed? Are they much better? It could have been the case that it negated the need for us to pursue this further, but we'll see as to what we found. And as I mentioned, the investigation of the regulatory frameworks. So the first thing is, this is brief, but it's only just to give you a little bit of a view as to the motivations. Why are we doing this? What might have changed? IoT sort of has changed, I think, and it is changing. So first of all, there's the growth. So it's clearly set to double by 2034. So high rates of growth. Now that doesn't change much in itself, but it's that growth in other areas, in medical IoT, which is seeing a far higher rate of adoption than traditional IoT, which we're used to. So that really is expanding a great deal. And we're looking at the critical infrastructure. So the movement to industrial and utilities growth is extremely high. So therefore, the security assumptions we've made, which is not really changed a great deal for home use, but is certainly changing a great deal for these applications. We're looking now, any of us in the room could have looked out. We all know that the rate of attack, the rate of attacks is going up, and it just depends as to who your measurements by. Just this week, the National Cybersecurity Centre in the UK reported a 50% rise in serious attacks. The Zscaler, which is particular to IoT malware, so is probably more focused on this, reported a 45% year on year. And then HIPAA, where we're looking at the medical records, showed a 13.7% increase. So we're seeing more serious and larger scale attacks. The cost of the breaches is serious, and so that's going up. That's 4.4 million, and clearly what it says is that the highest loss area is healthcare. So again, another factor which is driving the work. So, and what are there's many concerns with IoT devices. So we know that to some extent, trying to pin down the actual weakness is very difficult. But the IEEE vulnerability analysis report gives 2 million vulnerable end-of-life devices, and then the quote is that it's 50% threatened by high risk vulnerabilities. Now that's backed up by Palo Alto, and Palo Alto give that at 57% of devices being vulnerable in some ways. So these are the serious bodies who are analysing the devices, and I think it's just as and clearly the Palo Alto 83% reporting unsupported OSs. The bottom one, I think, is just as serious, because that is really saying, what do users feel about these devices? And if 62% are reporting concerns, and I think a lot of us would share those concerns, then it's really hampering the market. So it's not just a passive concern. So we're looking to approach this in the research in three different spheres. What the security, so the protocols, the support of secure DNS, their operation. We're looking at the behavior, a lot in that area in terms of efficiency and how they handle normal traffic. So we're looking at TTL, protocol implementation. And then we're looking at the controls, so the standards, regulations, and guidelines. So what's in place to actually keep these things operating in some sort of correct way. So we're not going to go through regulations. That'd be sort of just to say this is what we've done as a starting point. So we went through the standards. So there's lots of standards: IoT reference architecture, IoT device cybersecurity guidelines, cybersecurity for consumer IoT-based guidelines. That really gives the impression that everything's done and that our concerns should be finished, because these are published there, either standards or guidelines. What we're doing is only addressing the DNS IoT sector, and we don't find any particular reference in how the devices behave in DNS and what they should do in DNS. So this is a little summary, and I'm certainly not going to go through this, but I will say, so the column, the DNS and IoT, is where we're looking for specific operational or control guidelines. And we've been through all the major, what we think are the major publishers of standards. We don't identify any guidelines specifically for DNS IoT. So that's the first page. That's the second page. So we do see sort of, there are recommendations naturally, you know, and there are some which refer to DNS, but there's nothing for this platform with all its limitations of constrained hardware, limited CPU, limited storage. This is the area we are looking at, and this is where we're trying to improve IoT security, particularly on DNS. So our test bed, we got a simple some environment in our lab. So 35 consumer IoTs, giving quite a wide range of devices in their complexity, sophistication, but trying to represent a cross-section of typical used devices. We've got DNS unbound server, which we can configure to either do secure DNS or standard DNS. We can use it to manipulate packets. And so the two things we're doing here, we're doing passive collection just to see how did the devices behave. What are they doing in their normal operation? They boot up, we use them. What do we see in the DNS there? And then we're doing the active manipulation. So we are modifying the packets, so the DNS responses, we're changing the TTL values, we're changing the resource records, we're changing the number of resource records to try and see as to how these devices behave. But the test lab is fully automated. We can reboot all the devices, we can start experiments, stop. So it gives us a very good cross-section as to what's going on. First question is, this is going to be no surprise to anybody in the room, but you have to do the test. Do the devices support encrypted DNS? So of the 35 devices, none of them do. But that's fine. So as long as we know that, we know as to what we are working with and where we are. None of the devices support DNSSEC, which again is not really surprising. One thing which was a little bit surprising is that the DNS extension eDNS0, so to support larger payloads above 512 bytes, there was only one device supported that. So it's a very limited, a very limited implementation really as to what we're seeing. Whoops. Right. Then we looked at an old matter to see if it's still present, DNS source port randomization. And so clearly the security concerns were well known. An RFC was produced, measures for making DNS more resilient against forged answers, and that gave us the answer, but it hasn't been implemented all these years later. So we see that one device, whereas we should clearly have a completely randomized answers, one device gives from 1,066 requests, it gives 452 on one port, 134 on another port. So that's not random at all. The other one, two other devices give all the responses on one port or another. So therefore, there is no randomization. They're open to spoofing. They're open to malicious responses. I have to thank Ulrich Weiser, who worked with us at the DNS hackathon, the RIPE event in Stockholm, who did programming with us for a weekend on this work. So tremendous work by him. Transaction ID. So the means of avoiding spoofing is clearly to combine the transaction ID with the source port, and we see again serious problems that the devices do not perform this security. So we should have a range of 65,000. On the first device, we see a range of 8, so far from as to what we want. The next device is a range of 2. Everything's going out with either 0 or 1. The next one looked a little bit better at first with 0 to 4F. Okay, well, that's good. We're seeing some randomization, but it's only 0.12% of the entire range. So not great. And the last one, we see that the device increments its transaction ID with each request made. So again, the implementation is just all wrong. So one other concern we saw was that the device's use of hard-coded DNS. So the devices have got DHCP servers giving an IP address. That should be extremely positive in the fact that they should behave in the way which we expect. However, quite a number of the devices, well, 5 devices in this case, are bypassing the DHCP provided DNS and are using their hard-coded. And clearly the problem with that is if you've got a company which is implementing a control over DNS requests, it's doing DNS inspection to make sure the devices are not compromised, they're not going to malicious sites. And in this case, because they are going out to non-assigned addresses, it could well be bypassing security controls and leaking data to third parties. So your requests are really going elsewhere. So we identified those devices. We looked at the retry rate. So this is just to say, how do devices behave when you lose the DNS server? So, okay, in a normal network, wide bandwidth network we're all used to, it really doesn't actually matter a great deal. But in this case, some of these devices are using very, very low bandwidth connections. So they could be using Zigbee, they could be using Thread. You might only have 50K throughput, depending on the number of hops. And so if you're making frequent requests, and in this case, we're seeing between 10 and 20-fold increase, then you're really hammering that very, very low bandwidth network because you are frequently making these DNS requests, and you are reducing the battery storage. So if you have your thermostatic valves, your room switches, whatever there are which is battery powered, then that's certainly taking a big impact when these devices are not behaving in a controlled way. So we'd expect them to perform an exponential back off mechanism so that they really trail back the number of requests which they're making. We expect them to put in some form of jitter or delay so that they're not all transmitting at the same time. And we're not seeing that. So another concern. Device identification is a little bit open because these devices are clearly using unencrypted DNS. You can see in the payload what the domain that is being requested, but it was also seen that the devices are highly identifiable in the frequency, the timing, the length of the responses. So a lot of factors that say it's not just going to this domain, but it looks like it is this particular device. And that might identify cameras or sensitive devices. So perhaps, and I'm not saying the point, but perhaps there should be some padding or some mechanism. And the other point is that lots of devices do a precursor action before they do a DNS or just after. So they might do an ICMP request, they might do some other action, but the two things combined help to identify what the particular device is. The TTL, clearly the response, the device makes its request for its domain, it gets its IP address back, and it gets a TTL. And we would want the device to cache that and then to use that for the period of the caching. That is not seen to be happening in the IoT devices. Irrespective of what the TTL value is, the devices have a fixed, constant DNS query rate. What we did is we changed the TTL from either 0.1 or 1 seconds, just to give us an easy means of analysis. We then put it down to 0, and then we put it up to 11,000 days, which just seemed to be the biggest value we could get in. And so because of their lack of respect for the TTL value which it gets back, then what we see is that there's an increased DNS load because they're making more queries, running the battery down if it's a battery device, increased latency because they're not holding the value for the amount of time it has to go out, resolve, come back, then perform its action. So very poor behavior in terms of the mechanism, which should be there to actually provide the most efficient operation. IPv6 support is extremely limited. So we got a number of devices, I think, which actually perform the DNS queries with IPv6. We compared that to some published research, which has just been done recently, and that came out at about the same as the figure which we'd seen, and that's about 20%. And that's not even 20% of the devices are performing a full DNS function. So what we clearly observe is a general lack of support for IPv6. Then two last methods. DNS is susceptible to RR injection, so we modified the responses just to see whether they would accept them, and even though they are non-routable, specific for test purposes, we'll say the devices accept them. We're not surprised at that because these are basic devices, and it really should be done at the application layer. But it was just to see whether they accept anything, and they certainly do. This one is a little bit different though, because this one we expected a little bit more, and we send responses with 100 duplicated resource records. And what we see in that is that the devices fall over, they crash. They cannot handle the large. And what that means is we saw at the start, there was only one device that supported eDNS 0, which would handle the larger payload. If they don't do that, they should switch to a TCP. We don't see that. And if they don't do that, they should fragment the IP packet. And what seems to happen is that they do fragment the IP packet, but they have a lot of problems. And so 7 of the 35 devices were rendered inoperable when we sent back large payloads with 100 responses. Now, and that's what I've just covered on the duplication. Okay, so the findings, we give a summary. So I'm not going to go through this because it is just the results, but in a tabular form that actually we've said. So if anybody wants to look through this, so after, then that would be great. And again, just to finish off the results. So the conclusions, I'm going to skip through very quickly or just go through because they are all the points. This is just highlighting all the points we've said as to what they support, what they don't support, and the fact that they only give partial implementation of the RFCs. So clearly the two RFCs for the transaction and ports and the back-off mechanism. And I'm going to skip just because these are all the matters we've seen. So the means of addressing this, we identify that the existing standards and regulations do not address these points, and there's the reasons. And so what we want to do is to propose an IETF security and privacy for DNS IoT devices. So this is a best practice. We're not adding regulation, we're not adding standards, we're not trying to create any new mechanism because there's enough. We're just trying to put a best practice standard. And what we would do with that, this is the best practice guideline, which we've just launched in July. It's now at version 1.1, and this is where we're looking for engagement for people to contribute, to say, is this good? Are the ideas within the guidelines good? Can they contribute and add or question? I think it's fine to say. This is, a lot of the work is Jim Mosley and Infoblox here, so we have to give a great deal of praise for him. And what it does is, I'm not going to go through these because they are really addressing the points we've seen, and you'll just be of the mindset that you've seen what the problem is. Here's the answer, and clearly we cannot specify that devices must adhere to secure protocols because many of them won't. They don't have the hardware implementation to do so, but we do make the points of saying what they should do, some cases as to what they must do. Some of this is, so the EDNS, there's a paper which is just coming through to fruition, which has got to be addressed in our guidelines, which is DNS over CoAP. So we will be looking at that. There's really lots of matters there that we are going to, that we see will solve matters and make devices more secure and more efficient in their operation, more controlled. And our aim is to have the regulation bodies, the standards and the guidelines refer to this. That is the goal, that is our aim. And that's what we hope for. So there's our test lab. There's a little link there. We've got 200 plus IoT devices we've been doing. And these are the people who've been working hard on that, really on this work in terms of bringing it together. So I'm clearly only the spokesperson here today for this. So in conclusion, I'd like to just say that I'd be very pleased if any of you can look at the paper and make a contribution. And I'd thank you very much for your attention today.
Awesome, thank you. All right, this is a very good talk, some very good questions. Don't forget to state your name and affiliation. We'll start here on the left, Mike.
Wolfgang Tremmel speaking for myself. Did you also include open source based IoT devices in your tests, and what were the results?
We didn't. There is a good deal of scope for this. What we started, because I think at the start we didn't know as to what our findings would be, and so we only went for consumer grade products that reflect the commercial market. I think that there's a good deal, there's a very strong point for saying, how do these compare, as you say, with open source, and how do they compare with medical and sort of infrastructure. So we take it on board, but it wasn't done in this initial 35 device. Yeah.
All right, the other mic.
Thanks. Lars Lehmann from NetNode. First, I suggest, if you haven't already, that you also bring this to the attention of the DNS Operations Working Group in the IETF and make a briefer and more succinct presentation there for time reasons, because there's a lot of operational experience in that group that may not exist in the IoT groups. So just an idea. Second question, have you seen any commonalities between the behaviors that has led you to think that the manufacturers are using a common library, DNS library of sorts, that might be interesting to try to influence in order to improve things?
I take that board, and I can absolutely follow the logic, because the behavior should be to say, if these devices, and we saw some devices are using a single port, and then the logical question is, are they using the same libraries for their DNS operation? We haven't taken that, and I think we're looking to interact with some manufacturers to begin delving down deeper into that now. But it is clearly recognised, and it would move us forward. I think we're going to see how far we get with the best practice guide, and that will help us to decide. But I take it on board completely.
Thank you.
All right, we're going to stop any new people joining the line, and then this microphone.
Jen Linkova, someone who tried to make some IoT devices to work over V6. First of all, I sorry if I missed it. Your document, which is definitely very useful because there are so many different standards and expect that hosts must implement all musts and should implement all should, is unrealistic. Is it DNS specific, or you're making kind of IoT host requirement document, which I think might be very useful the same way V6 Ops produces CPE requirement document, for example, right? So we do know what to expect from a CPE router, for example, right? Out of all this huge set of standards.
We are aiming, we've got to be focused in this. And I think the IoT breadth of security areas is so wide that we have decided to just go with DNS on IoT. I think once that comes through, if we can get that through to a best practice, then it leaves the next question whether there should be a best practice for the whole of the IoT. At the moment, we're being very, very focused on DNS IoT. But, yeah.
Thank you.
Hi there, Tom Hill from BT. I'm hoping that I might be able to put you in touch with one of my colleagues at some point, so we'll have a chat after this. The main question I have is very similar to Jen's actually, but it was more about making sure that we've actually thought about best practices for IPv6 and IPv4, so it's happy eyeballs behavior and things like that, because there have been some instances, very notable instances, of devices, very common ones in the home, doing very strange things when presented with IPv6 DNS resolvers.
Yeah, it's well. Clearly, one of the recommendations will be the support of IPv6, and Matter is going IPv6. There's a lot going IPv6. What I think though is the case now. So I'll just be brief then. You gave an opinion there, and your knowledge within that area of IPv6 may be. Your experience may be far greater than ours, and that's where we're looking to have. Contributions. So the IETF means of putting this forward is to try and encourage people to get onto the mailing list and put in a view. So rather than me clearly saying now that I think that you are right or that we disagree or something, what we're looking to do is to harness the skills and the knowledge for people to contribute. And if that is a push towards IPv6 or against IPv6 in some ways, then that's good.
Sure. Well, we'll be at the IETF in a week or so we'll be able to have a look, hopefully.
Be good.
Thanks.
All right. Any online questions? I'd just like to throw out there then Valerie Aurora, Baushock Systems Consulting. You can get paid to work on the Cyber Resilience Act IoT standard. Check it out. Thank you very, very much for this very important talk. I appreciate it. Okay, our next talk is IPv4 versus IPv6 for authoritative DNS by Shane Kerr from IBM NS1 Connect. Thanks, Shane.
Thank you. Good morning, everyone. It feels good on a Friday morning to be nestled in between two other DNS talks. So this is a lightning talk, just a very short thing. I wanted to mention a little measurement that I did. Basically, I work at IBM NS1 Connect. We run authoritative DNS, Anycast Cloud, and one of our customers was asking our business people, how good is our IPv6 network? And so they were like, oh, we're just going to tell them it's great. I said, no. maybe we should check. And so that was what I wanted to do. And so well, the way I decided to do this was I set up a DNS zone that all of the name servers only resolved to quad A, meaning that it was only accessible via IPv4. And then I did the same thing for IPv6. And I ran it through a little zone checker you can see on the bottom. I will note that there were no warnings about only having IPv4 addresses, but there were warnings about only having IPv6s. So that's the first thing we could do to improve the universe. Yeah, and you see that for each of these zones, I picked just 1,000 RIPE Atlas probes. RIPE Atlas is great. If you don't know anything about it, please check it out. It's a really awesome system for doing these kind of ad hoc measurements, especially in the DNS space. So I picked 1,000 random probes, and then I queried a TXT record in this zone, and then I did it again. And the reason I did it again was so that to increase the chance of all of the rest of the stuff being cached. So when you do a DNS resolution, it's got to chase down from the parent all the way to the zone itself. And all these things need to be cached. So it's not a perfect solution, because if you're using, for example, a big public resolver, or if you're at an ISP with a lot of resolvers, they probably run a cluster, and you might end up at a different server which doesn't share cache. But I wanted to increase the chance of that. So what I wanted to have as the actual measurement is the probe queries its local resolver, that resolver queries the authoritative server. So basically 2 lookups, and that would be the whole test. So anyway, what did we see? I made a nice graph of the response times. I cut it off at 500 milliseconds there. The timeout by default, I think on RIPE Atlas is 5 seconds, but that makes the graph very hard to read because there's a bunch of white space. So you can see, and which is which? The orange here is IPv6, and the blue is IPv4. And so what we see is, in this case, IPv6 is a little bit faster. Great, everything's good. Yeah, that's basically it. Now, if you look at the top, it's a little hard to read because the font's a bit small. We say average per probe. The issue here is that when a RIPE Atlas probe tries to figure out what resolvers there are on the network, is it gets whatever DHCP tells it. And really, for most of the time, there's like 2 or 3 different IP addresses that come back. And so what we can't know is, like, when your laptop gets that, it may have a different sort of heuristic for deciding which of these resolvers to query in which order and things like that. It could probe them all once to see which is fastest. It might just pick the first on the list. It might pick the first on the list until that gives a serve fail and then move on. We don't know. So in this case, I just picked the average, and that's what we see here. Now, well, yeah, here's a summary about that. So we see it's like about 3% difference when we look at the mean, which is fine. It's basically the same. And like I said, though, we have multiple resolvers. So the hypothesis is that people setting up their networks are probably going to put the fastest resolver first, and the others are backups in case something goes wrong. So if we just pull out the fastest result, then the graph looks slightly different, and the sort of improvement of IPv6 over IPv4 becomes less. But it's still basically the same. So I think the first thing to take away is that, well, just to go over this just a little bit more. I don't know which of these graphs is closest to what people see, but they both tell the same basic story, which is that for our edge, for this last part of the query lookup, IPv4 and IPv6 are basically the same. But I don't really want to talk about any of that. What I want to talk about was something I noticed just at the end of this thing, which is that of these, you ask for 1,000 measurements and you get some number almost that much, not quite, because right Atlas has some weird like non-deterministic methods of figuring this stuff out. It's fine. But for IPv4, 97% of the measurements that got submitted ended up with the correct answer. In IPv6, it was 96%. So what does that mean? What does that mean that we don't need to use IPv4 for authoritative DNS anymore? Maybe, I don't know. I think we can certainly say that all of the cautious requirements that we've had in the past for saying, make sure you have 2 IPv4 addresses, and if you want to, you can add IPv6. That was strengthened more recently, saying you should add IPv6. Maybe we can say you just have to have IP. And if IPv6 is cheaper, it's probably good enough. I don't really know. That's it. That was all I wanted to say.
Hi, Jen Linkova. Question. So you got 1,000 random probes. How distributed were the resolvers? Because maybe most of them were using like a few very well-known resolvers versus getting 1,000 probes with random resolvers. Like
I did not limit the probes at all. I just said, give me 1,000 probes globally. And I did repeat this test with basically identical results. Okay. And the queries from the probe to the resolvers were done over IPv4. So.
Yeah, and so it also means you did not try to distribute them between different IS. No, okay.
No. And I realize if you're running a resolver on your laptop and you're in a crappy hotel network, then you can't get to an IPv6 only network or authority.
Hi, I'm Mark van der Wal at Afnic, also developer of that little zone checker tool that you mentioned in your slides.
Thank you. That's good.
So thank you very much for that research. And feel free to open the GitHub issue if you feel that we should change the warnings.
I will do that. Great. Thank you.
Peter Hessler, thank you very much for doing this research. It's great seeing it quantified and actually documented. I've also done a number of other IPv6 only experiments of not just DNS, but other services. And my concern is for the audience, if you want to run IPv6 only services, is be aware of who your users and customers are. And the vast majority of people would have access, but if the ones that you want to serve don't, then you are doing a disservice to yourself, unfortunately. So just be aware of who's trying.
I know I'm over time, and I'm going to say I agree with that, but I also think we're at a stage in the internet now where that's also true on IPv4. Like, why are we so worried about IPv6 when we just assume everything's fine in IPv4? And I think we're past that now.
Absolutely, yeah. Dual stack at minimum.
Yeah. Thank you.
Okay, thank you so much. Do we have any online questions? No? Okay.
Shane, you got time for one more question?
Sorry, Shane. We have one more question.
It just came in, sorry. From Simon Lanin from Switch. Might the population of Atlas probes be biased to overestimate IPv6 support? i.e. people who'd run Atlas probes are also likely to have working IPv6.
Yes, this is very much scientism. This is not science. This is just one measurement result. Well, a few measurement results picked at random. If people want to do more rigorous research in this area, I'm happy to collaborate, but I don't really have any more plans right now. So, yeah.
Okay, so while we thank Shane with a big applause. If you think that his presentation was good, please rate it. You have the URL in your email, please use it. While the rest of us try to fix things, there is someone who tries to break them. So I'm going to introduce you to Mark van der Wal, who is going to talk about the intentionally broken DNS server. The stage is yours.
Well, hello. Hello, everybody. I'm Mark van der Wal, so R&D engineer at Afnic at the Registry of .fr domains. Today, I'm going to give you a little update on one of my projects called IPDNS, because I've had the chance to use it for something interesting, and I thought you'd like the story. So first of all, why do we even need or want a server that intentionally misbehaves? So think of it as a testing tool, and a testing tool to make sure in this context that, for example, Zone Master gives us the right diagnostics in the right situations. And also because I think it can be useful for other situations, making sure that your IoT devices don't catch fire, for example. So I thought I proceeded with this project, which I started 3 years ago. And this is me at DNSOARC 39 talking about this intentionally broken DNS server for the first time. Back then, it couldn't do much, but then since then, I added many more features, like, well, mostly centered around RFC 1034 and 1035. It's released as open source as well, under GPL v3, and I've added a lot of documentation. And this is me 3 years later, at the beginning of the month, actually, at the DNS Hackathon in Stockholm, organized by Internet Stiftelsen, DNSOARC, and NetNode. And among the projects that were submitted, there was a proposal to implement a draft that would give us, in addition to the BGP clock that we saw earlier this week, a DNS clock. So how it works is kind of like NSID. A client asks for the time in the DNS, and the server returns the time in an EDNS option. And so Lars Lehmann and I teamed up together and started implementing this feature. Lars had some patches for bind and dig, and while I started implementing it in IBDNS. So this is an excerpt of the configuration file that I had running on a public instance of IBDNS, which was useful for Lars to test his version of dig, and also for other people to play around. And this gives you an idea of what I came up with. Do everything right by default, or according to the query name, it would exhibit different behavior, or like returning random bytes instead of the correct time, or skewing the time by a fixed amount to simulate a server that was way out of sync. And so off we went. So this is how it looks like when things are operating normally. So with the patch version of dig, you add the +UTC option and you get the time in the UTC stamp EDNS option. And so then I said to Lars, okay, all's fine. Try this domain instead. This happened. Well, that was the first iteration, so clearly it wasn't ready for production yet. Second iteration, he added some checks for return values of C library functions, like you should, and this is how it should operate. And I had a few more edge cases that resulted in him writing a little test suite in the form of a shell script, and the shell script would just query a lot of names and we'd compare manually with the expected behavior. So I guess that was nice. So what did we take home from that hackathon? 2 server implementations of that UTC stamp extension in bind and in IBDNS. So 2 independent implementations. Also, it works in dig, and dig will not crash even if we throw the worst garbage possible. So this is ready for production. And also, IBDNS did not support EDNS at all until now. So it was a good opportunity to have it implemented. It was on the roadmap, but I just didn't get to do it until now. And also, last but not least, let me introduce you to a new DNS animal. So some of you know of the DNS camel, but Jonas Andersson from Internet Stiftelsen made this DNS cat, and he very kindly let me use it as the official mascot for IBDNS. So thank you very much, Jonas. Okay, so also it goes to show that good contributions to open source do not have to be code. It can be ideas, but also mascots. Anyway, so if you're interested in the source code, here's the link to the GitLab repository and the obligatory QR code as well. And with that said, I'm happy to take any questions. Thank you.
No,
Sorry, can you state your affiliation again? The mic was cut off.
Sorry, Lars Lehmann from NetNode again. So thank you. This was absolutely top fun. We had so much fun doing this, and this shows two things. One is how the hackathons work, and the immediate and very cheerful and good interaction you can have during a hackathon. This brings things forward very rapidly and efficiently. So please go to hackathons. It's great fun. The second one is that before this, I had my slight doubts about the usability of IBDNS. But as we sat there and my code just crashed, I realized how important this tool is as a testing tool. IBDNS is really, really useful. So for those of you who develop code and implement code, please make use of IBDNS because it's actually very, very useful to test your code. I'm quite sure there are new ways to make my dig crash, but it's probably not going to be the UTC stamp. Thanks.
Well, thank you very much for that comment. And yes, I second that. It was really great teamwork.
Marco Sanz speaking for myself. Serious question, how do you come up with those test cases? What kind of legal or illegal substances you consume to come up with those ideas?
Well, first of all, I'd say my general methodology is to first read the RFCs and kind of anticipate what could go wrong in, for example, naive implementations. A good example of that is the handling of empty non-terminals, which is something that's in RFC 1035, and yet modern-day implementations still get it wrong, and IBDNS can replicate it.
Thank you.
Any questions online?
Neil O'Reilly, just another member of the community. I want to echo what Liman said about hackathons. I was at another one in March, and it wasn't the project I was working on, but there was another tool similar in some senses to this one called canned DNS, which gave you the possibility to configure deterministically broken responses which were repeatable. And other clever tool. I'm sorry, I forget whose initiative it was. I wasn't in that group.
Okay, I think it must be Mats Dufberg's initiative, also from Internet Stiftelsen. Actually, the idea for that tool also came forward from the discussions I had with him about IBDNS. So, and it's also, yeah, synthesizing responses like CanDNS does is something I'd like to do as well, and would be a very useful feature in IBDNS, and would let us finally test ZoneMaster really systematically with IBDNS for everything.
Just one more question from me, Valerie Aurora, Baushock Systems. Was the author or the artist of the logo at the hackathon, or was any more details on that?
Yes, he was.
Yes,
and
awesome.
Yeah.
Cool. Thank you. Thank you. A big round of applause. That was amazing.
Just to follow, Jonas Andersson is one of the DNS experts at DNS Labs at Internet Stiftelsen. So, yes.
Dual purpose. Okay, great. All right, don't forget to rate the talks. And next up, we have Dave Phelan from AppNic. Filter your things, or no, I don't want to use your NTP server.
Good morning, everybody. This slide deck's gone through a few working titles. It started out as no, I don't want your customer details. No, I don't want to use your NTP server, but eventually I settled on filter your services. So who am I? I'm a network and infrastructure engineer for a long time. I'm now the policy manager and senior network analyst at APNIC, and I like the odd cat meme from time to time. So knowing that I'm what's standing between you and coffee, I'm going to try and blast through this. So I'm going to talk about some numbers that I collect a lot in my region. And Tom Strick's talk on GNMI got me thinking, well, how much bad SNMP is there around in this region? I don't do a lot of checking in here, so I thought I'll have a look. How many services are unsecured? And bad news, it's lots. So if we look at DDoS by layers, obviously the area I'm going to focus on is up here in layer 5, 6, and 7, which is reflection, amplification, etc. So for those that are uninitiated, attacker wants to go and break some stuff, so they contact Dave's DDoS bot rental service, and I go, that's fine, I will go and deploy a botnet for you. Here you go, here's your botnet, and we go and ask the botnet to get all of its bots to query a specific A record. So the open recursive resolvers go and get the specific text record that I have in my domain. It goes to the, all of these open resolvers. We pull back the actual record from my evil.com domain, and it will then respond with this 4K record and then go and attack my victim. And eventually my victim will hopefully catch on fire and we move on with life to our next target. So why reflection and amplification? Well, UDP is a really great reflection target. It's we can spoof it easily, it's connectionless, we don't have a three-way handshake. And amplification, anything that gives us a good result in terms of small query, big response. So DNS is great for that because we can get some variable size responses, but there are much better protocols or better services. So SNMP can be a little bit random. DNS is fairly consistent, but my two favorites are NTP and Memcached. So who's doing what? I had a quick look around the ripe service region. I had to modify some of my scripts to actually pull out the ripe service region. And this is what we found. So when I look at NTP servers, so these are all open 1, 2, 3, anywhere between a stratum 2 and a stratum 12 time server that I see around the traps. No surprises on Russia being up the top, but Italy, 230K. I had a bit more of a look into some of these devices. Again, I've got some more scripts that do some random sampling on the results, and it's mostly consumer CPEs. All of these consumer CPEs are sitting on public v4 with open port 1, 2, 3. I don't want to query your time servers. So my question is to the operators, why are you not filtering these services towards your customers' residential blocks? Your residential customers pay you the least, and you're giving them everything. Should we be doing this? I don't know. I hear arguments for, I know I'm just a carriage service provider, clean feed, but we should be securing our networks. Don't put it in the realms of the security teams. This is a job for all of us. Romania wasn't on the list, so I had a quick look. They're sitting at 7th at about 90K. Just as an aside, when I look at the global numbers, typically I see my corner of the world feature fairly prominently. Usually it's US, India, and then a ton of other APAC countries. So the fact that we don't tend to see the European countries or the ripe service region up there is not surprising. We have a quarter of the world's population just in 2 countries, so it's going to happen. So SNMP v2. Now this one scares me more than it should. This is only things that have responded with a read-only community of public. So these are things that are in default mode. Italy. I found 3,000-ish Cambium wireless devices. So they clearly belong to, I'd say, a wireless ISP somewhere. Anybody know what the default configuration of a Cambium AP is? Read-only community is public. Guess what the read-write community is? Private. Guess how many of them now have a new system description? No, I didn't do that, but yes. A lot of them were set for still default private. So they've gone and thrown an IP address on them and then just put them out into the wild. So Italy, Russia, Poland, Spain, Sweden. DNS recursive. Now again, this is only DNS resolvers that will actually have recursion enabled. And I again run a sample set of queries to make sure that most of these are actually functional. So Russia, Spain, Ukraine, Italy, Poland. Romania sitting down there in 16, so good work. Now this one we shouldn't be talking about in 2025. MemCached has the highest bandwidth amplification factor. This was a problem in 2016, which we thought we'd solved. Filter port 11211, MemCached problems go away. Clearly that is not the case. Now this is an area where the European side of the world outstrips the APAC side. We don't have this problem to this degree on my side of the planet. So if your country is on this list, please go and have a look at your networks. So prevent your services from attacking others. Do things like rate limiting. Please do BCP 38. It's only been around for a couple of years. It's still pretty new. It's gaining adoption, but we're getting there. Securely configure your DNS and NTP and SNMP servers. We don't need your public SNMP data available to everybody. One other note, one of those SNMP servers was also from an Italian ISP who was downstream of Telecom Italia that had one of their BNGs wide open. 2,500 customers sitting on that BNG. I have their usernames if you want them. No open resolvers. If you are running recursive resolvers for your customers, please lock them down to your customers' IP address ranges. These are common things that we're not doing. If you don't know what you don't know. Check your own stuff with Shodan or subscribe to the Shadow Server reports. It's not hard. These are all free things. Sources for my data, Cybergreen, Shodan, and cats of the internet everywhere. Any questions?
Marco Ditri, CWeb. Great work. The problem, of course, is that the people who should be fix this are not here. So please name and shame so that when we go back home, we can mock these people. Thanks.
In my own service region, I do that, but I don't do it when I'm traveling. I like to come back to other countries from time to time.
Peter Hessler, in the past, Redis was also a large source of this problem. Redis had a change in their default distribution, however, to set it to localhost. I was curious to listen only on localhost. So I'm curious if you checked Redis and if there was a significant difference that you saw.
No, I didn't. I just literally just took my bolts and just looked at it. Yeah.
Thanks.
I literally threw this together at 5 a.m. on Tuesday morning. So
valid.
Oh, no, one more.
One small question. Is your rating looks like amount, Alexander in Moscow, Internet Exchange. It looks like from the amount of device, but could you check all amount of the device in the country, because the country is completely different size, so it could be different in the ratio.
I have a much longer version of this presentation where I dig into per capita type rates and that sort of stuff as well. Obviously for a lightning talk, I just want to hit the headline numbers and let everybody else work the other bits out. So yeah.
Okay. While we thank you so much, Des, for your presentation. A big applause, please, everybody. We are just on time for a well-deserved coffee break. Before we run out, please do not forget to rate the presentation. This is really valuable information we need from you. Just not in the case that we make it right, but also in those cases where you think things can be improved. Thank you so much.
it's over, right?
Yes.
Okay, for those of you who are interested in voting results, it will start in a few seconds. If you are not, feel free to go for some refreshment outside of the room. So if I can get a little bit of attention, even from Rudiger. So let me finish the stuff we started on Wednesday afternoon. Here are the voting results from the general meeting. You remember that this general meeting wasn't very rich of voting. There was just one resolution, and there is no surprise in that. So the supermajority of the members voted in favor of the resolution number 1. So in case there will be a nexus contribution, this will be redistributed. And if there will be deficit, it will be covered by RIPE and CC reserves. So no surprises. Almost 90, more than 92% voted in favor, 7% against, and just 9 votes abstained. So really no surprises here. And last announcement, I have to thank João Damos for being independent observer. So please help me to thank him. And with that, I'm closing the general meeting. So the general meeting is closed. Enjoy the last session of the RIPE meeting and see you all in Edinburgh. Thank you very much.
Okay. Hello, hello, hello. Welcome to the closing plenary session of RIPE 91. And before we kick off, I just want to announce the results of the PC elections. And huge thanks to everyone who volunteered. It's a big thing to put yourself forward, and it really is appreciated. And we need, there will be more chances for those who were not successful or those who looked at it and went, maybe I could do that. So huge congratulations to Annika Hanig and Matt Parker for being elected to the PC. And I want to give equally huge thanks to Valerie Aurora and Franziska Lichtbau, whose terms have ended and have been wonderful, as you would expect, because they are wonderful people for the last 4 meetings, and they will be missed. Okay, so we're going to move on to the first talk, and Maynard is, yes, so Maynard Koch is going to talk to us about transparent DNS forwarders.
Okay, so hello everyone. Welcome to my talk about transparent DNS forwarders and their misuse potential in DNS amplification attacks. My name is Maynard. I'm a PhD student from TU Dresden, and this is joint work together with Florian, Thomas, and Matthias. So I assume that everyone has ever heard of DDoS attacks. So they're nowadays a common threat, and often DNS is misused in these attacks. So an attacker just tries to craft some lightweight queries that create large responses and then flood the victim with unsolicited DNS responses. So the open DNS infrastructure is often misused in these attacks, as these components can serve as reflectors or amplifiers. To run a distributed attack, the attacker, for example, if he has access to a botnet, he can misuse open recursive resolvers and issue queries that are spoofed DNS requests, and then the open recursive resolvers amplifies the queries and flood the victim with amplified DNS responses. But we consider botnets are costly, and we want to show that there are alternatives an attacker could misuse. For example, open recursive forwarders. So forwarders are usually globally distributed, and they enable distributed attacks without a botnet. So the attacker could issue spoofed DNS requests to the recursive forwarder. The recursive forwarder then initiates a new connection to their configured recursive resolver. There's the amplification that comes into place. And of course, the IP address is here the IP address of the recursive forwarder. So the recursive forwarder has to handle the amplified response and then sends back the amplified DNS responses to the victim. So of course, there's no need for a botnet in that case, but the recursive forwarder has to handle the amplified response. And the problem here is that forwarders are often constrained devices. So the question is, can an attacker be more efficient? And yes, he can. And that's where I want to introduce to you the transparent DNS forwarders. First of all, they are misconfigured devices. So they are not intentionally deployed, but they're mostly vendors that have transparent forwarders. They mostly ship them without knowing that they are transparent forwarders. So an attacker could issue spoofed DNS requests towards the transparent forwarders. And what happens next is that the transparent forwarder initiates a new connection with their configured recursive resolver, for example, Google's Quad 8, but they do not rewrite the source IP address. So that means they forward traffic that has a spoofed source IP address through the network, and the recursive resolver then allegedly receives a DNS request from the DDoS target. So it just amplifies the DNS requests and floods the victim with DNS responses. So there's no need for a botnet, and there's also no need to handle the amplified responses. So the question is, what is the actual misuse potential in DDoS attacks and DNS simplification attacks when an attacker would use transparent forwarders. Because in the past, the little attention has been paid to transparent DNS forwarders. And several monitoring campaigns that are well known, they still do not monitor transparent DNS forwarders. They only monitor open resolvers, recursive resolvers, and also recursive forwarders, but no transparent forwarders. So the problem is that they, of course, provide an additional attack infrastructure. They are more than 30% of the OpenDNS infrastructures are actually transparent forwarders. So in total numbers, in absolute numbers, we measure about 540,000 transparent forwarders in the wild per measurement. So that's not a total over time, that's just one measurement. And what you can see here is a world map of the global distribution of transparent forwarders per country. So we find them in about 175 countries. And most of them are actually active in Brazil and India. So there is a regional bias, of course. And apart from just providing additional attack infrastructure by their existence, they also enable access to what we call shielded resolvers. So these shielded resolvers should only be accessible from the internal network. So firewall rules at the network borders, they filter requests that directly target shielded resolvers. However, if there is a transparent forwarder in that network, you can just target the transparent forwarder, and the transparent forwarder then relays the request, the DNS request, to that shielded resolver. And sometimes they are not properly configured. So that means that they have no firewall rules at the resolver, because they just assume every traffic that receives these resolvers is legitimate because there are some firewall rules at the network borders. So that means with transparent forwarders, you can trigger remote responses from without the network where it shouldn't be possible. So in our measurements, we find about 30,000 shielded resolvers that are accessible through these transparent forwarding devices, and they're distributed in about 1.9 thousand autonomous systems. But they not only provide an additional attack infrastructure, they are also way more efficient in potential attacks. So we try to fingerprint these transparent forwarding devices, and we find about way more than 20 different vendors, where MikroTik is the most prevalent device type. They range from constrained IP cameras up to powerful data center routers. So the majority of transparent forwarders, at least that we fingerprint, are CPE devices. So the question is, can they be misused efficiently in DDoS attacks? First of all, the initial thought was that, of course, they are way more efficient than recursive forwarders because they do not need to handle the amplified response. And to verify that, we've set up a testbed using a MikroTik router, which we found during fingerprinting. And we once set them up as a transparent forwarder, and we also set them up as a recursive forwarder to compare them how they would perform in an actual attack. So we did this in a lab measurement setup. And what you see here is on the x-axis, the transmit traffic, which means this is the DNS queries we issue towards the router. And then on the y-axis, the attack traffic that is received by the victim after the amplification at the resolver. And what you can clearly observe here is that the recursive forwarder quickly reaches its maximum attack rate. So the router already runs into resource limitations at about 1.5 Mbits because it has to handle the amplified DNS response. But the transparent forwarder reaches like 6 times more attack traffic at the victim because it does not need to handle the amplified response. And therefore, it does not run as quick into resource limitations as the recursive forwarding version does. So transparent forwarders pose a serious threat on their own. But what happens when an attacker starts to orchestrate them, to use them in distributed denial of service attacks? And that's where an attacker could try to avoid these local rate limits by orchestrating these transparent forwarders. So to start with, we assume the attacker controls a single vantage point, no botnet. And without the botnet, if the attacker tries to, for example, misuse Anycast DNS infrastructure, he only reaches a single point of presence of this Anycast infrastructure. For example, Anycast infrastructure of Google's Quad 8. Then there are some local rate limits, of course, that prevent an effective amplification attack. So we also measured the rate limits at several locations for several public DNS providers. In this case, Google's resolver, for example, rate limit between 500 to 3,000 queries per second. But that was dependent on the location where we measured and of the day, what was the actual load on these resolvers. So, of course, an attacker can, if he has a botnet, control over a botnet, circumvent these local rate limits by just having a globally distributed botnet and attacking multiple instances of the Anycast infrastructure. But we found during our measurements that more than 75% of the transparent forwarders actually relay their requests to Anycast infrastructure, such as Google's Quad 8, Cloudware's Quad 1, and, for example, also OpenDNS. So an attacker could just orchestrate these transparent forwarders to circumvent these local rate limits by just hitting multiple point of presence instances of the public DNS providers, for example, Google. So the attacker could carefully select a set of transparent forwarders that hit multiple point of presence, and then the victim, of course, receives a flood of DNS responses. So we tried to verify that in the wild by conducting some measurements, but we did not use any amplification here, of course. We showed that you can reach an amplification factor easily of up to 14 because the rate limits vary by orchestrating 10 transparent forwarders, which means of course, due to ethical considerations, we only issued lightweight DNS queries. So no amplification here. We only did it for 10 transparent forwarders just as a proof of concept. And we, of course, limited the experiment time and so on, so that no overloading of the network paths was happening. So what can you do against that? As soon as we noticed the problem with the transparent forwarders, we started to contact network operators. And we actually succeeded by reducing the impact. Our responsible disclosure removed about 250,000 devices from the threat landscape because a large European fixed their firewall configuration, as mentioned earlier, with the shielded resolver. So they started to prevent access from other devices without being in the network. So that is the first main key takeaway here. So verify and update your firewall rules if necessary. And of course, these transparent forwarders initiate a new connection to the recursive resolver, but they just use a spoofed IP address there. So that's a clear indicator that all networks, or most of the networks where we find transparent forwarders, do not follow BCP38, which means they do not implement network ingress filtering. So the solution is rather simple. Please implement network ingress filtering in your network so you can ensure that only traffic from allowed ranges passes through. And of course, mitigation is possible by strict rate limiting. So of course, local rate limiting of public DNS resolvers, and also global rate limiting in case of the orchestrated nature of such an attack. So there should be a global monitoring strategy to detect such anomalies. So I know it's late, but it's time to wake up, I think. Here are some statistics for the RIPE region. These are the top 10 ASs that host transparent forwarders. I find in 74 out of 76 countries of the RIPE regions, find at least one transparent forwarder. And in total, we see about 47,000 transparent forwarders. And there are also some dense regions, so the top 10 RSs are mostly located in Eastern Europe and in Western Asia. There's also, that's quite nice, because in the attendee list, there are some ASs listed, so I checked all of them, and I found that on site at RIPE 91, there are actually 32 ASs that host at least one transparent forwarder. But what can you do now? Of course, check if your network is affected, but how? We, of course, provide all our measurement results publicly under odns.secno.net, and we also provide access via an API. So, yeah, now it's time. If you want, you can put out your laptop and copy and paste this API call, because we do weekly measurements. We update our open resolver list once a week. It's easy to integrate. You can add our API to your monitoring setup. The data is returned in JSON format. Of course, we are open for feedback. What you can see here is a temporary API key, so you can actually just copy-paste the query for now. It expires on Sunday, but we found it a nice addition to have a working API key, so you can test it out immediately. We require pagination, but it works smoothly for up to 100,000 entries per page, which should be enough for most of you. And you can just replace the queried IP ISN value here with your AS number. You can also check for a complete list per country. There are many more features, but of course, yes, please check if your network is affected. Why? Because transparent forwarders are misconfigured devices. They allow for significantly higher attack traffic, and they can be orchestrated to circumvent local rate limiting. Of course, they allow access to, or they allow to bypass shielded resolvers, which is not good. And eliminating the impact of transparent forwarders requires little changes. So my call for action here is, please check your firewall rules and update if necessary. Implement network ingress filtering, and check if your network devices are affected. So use our API or reach out to us. And if you want to know more about the details of our measurements, of our methodology, and so on, you can check out our ACM CCS paper. And with that, I would like to conclude my talk, and thank you for your attention.
Do we have any questions? Don't see anyone. Oh, Will is coming.
Mike, yeah, thank you. Sorry, it's not a question, it's a comment. I think there's, sorry, I'm Will, user of Resolver and funny stuff like that. I think there is a document, ASNs that can be used in documentation for the API thingy there. Because I think it was 1, 2, 3, 4, 5. I think it's unassigned. It's still right region. Please don't do that. Thank you. But rest of the talk, really cool. Thank you very much.
All right.
I will tell you.
Thank you very much.
I don't see any other questions. I didn't see any online until I turned on. We still have a few minutes. Okay, Peter.
Peter Hessler. Unfortunately, the ISP I use at home does do transparent DNS hijacking occasionally, and it ruins my day every time they do this. So my call to action to the community is don't do that. Turn this off. You are hijacking and making everyone's life miserable when you hijack DNS requests. Allow them to go to the server.
Yes. Thank you.
Tom Strix, operator of a recursive resolver. Can you speculate on what kind of the potential legitimate use of like a transparent forwarder is within these ISPs? Is it literally just oopsie whoopsie fucky wucky configuration, or?
Yeah, more or less. I mean, I think there's no such use case for transparent forwarders. Maybe it's cheaper to just forward the queries instead of having to resolve the query handling the amplified response. So you just have a forwarding rule, put in your resolver, and then give it a go. But yeah, there's no actual use case for users or users of the ISP to host transparent forwarders.
So what you're saying is IP tables were a mistake?
It depends.
Thank
In
you.
this case, maybe yes.
So, Andre, IFC, implementer of DNS resolver, but speaking from experience, people don't know what they are doing with their DNS. Like there's configs inherited from the guy who left 10 years ago.
Yes.
And I've seen compilation options that has been no longer operational for 15 years and still being in the config. So this does not surprise me at all, because there's not enough knowledge out there for people running stuff. So this community is like the exception. The rest of the world is like waving hands, running, screaming around, and hoping that this stuff works. So I'm not sure if we can do anything about this, because those people are just like oblivious.
Yes, thank you.
Rüdiger Volk. Well, okay, we had a couple of sessions where know your customer was a requirement or a request. Actually, the even more important thing is know what you are doing. And in this case, I think essentially, well, okay, the usual residential customer cannot really be blamed, because my grandma is not supposed to figure out what's happening there. Exactly. But the know what you are doing, of course, is a requirement that we should be imposing on the equipment vendors if they decide that for whatever commercial reasons, the implementation of transparent forwarding is to their benefit. They really should be required to do proper default configuration.
Yes.
Because that would essentially prevent grandma's net to operate as a bad.
Definitely, and no network operator needs to do anything then. Thank you for your comment.
Dave Phelan, APNIC. As the token Australian in the room, I felt attacked by your graphics.
I see no one else in the queue, so I would thank you very much.
Thank you very much.
So next, she presented about this at the previous meeting, the last meeting, but she wants to give us an update about Internet Resiliency Club. So here's Valerie again.
All right. How's the sound? Sound is good. Okay. Yeah, Internet Resiliency Club update, what we're doing for grassroots emergency preparation in Amsterdam specifically. A little bit about me. I work for Baushock Systems software consultant with 25 years of experience doing things like Linux, file systems, networking. I'm now the special rapporteur for the Cyber Resilience Act standards for the operating systems and network interfaces standards. Boy, network interfaces do a lot of stuff now. Also, this was a huge mistake. Never do this. I'm also the founder of the Amsterdam Internet Resiliency Club, and here's some undersea submarine cable splices from the Museum of Communications in Lisbon, last event. All right, so some background. The internet and power disruptions are a concern. We all know why. That was amply proven this year. If you're concerned about losing both power and internet, a mesh network using low power radios could provide text communication during power and internet outages. And you could use that to get your power and internet back, which would be really great. So the estimated date for the government in Amsterdam and the Netherlands as a whole is to get around to doing this is 2028. I kind of think we might need it before that. So what if a bunch of internet experts decided to buy low power LoRa radios and connect them with some kind of decentralized mesh network? So we had our first meeting of the Amsterdam Internet Resiliency Club in January 2025. and we managed to accomplish some things. We now have monthly in-person meetings. We have almost 20 members, many of whom can definitely fix the internet. Also a lot of ham radios, hams who have ham radios. We have actually sent each other messages over our private Meshtastic channel. Private, it's 8 bits. So here's what the conversation here in Bucharest. Wolfgang says, I couldn't attend the reception. Wolfgang says, beer and food is okay, but nothing special. Little did he know how special that beer was. This is a very common kind of communication ping pong ack. Somebody forgot their node, and I'm going to add Wolfgang's SenseCap card to my lightning talk if accepted. So you have something to look forward to. So we managed to get WAG Future Lab to join forces with us. They've been working on Meshtastic and mesh networking for quite some time in Amsterdam. Various members of the Amsterdam IRC, the acronym is intentional, have applied for around 50,000 euros in grants. We've received 10,000 so far, and there's 5,000 in progress. We had a reporter for New Scientists come to a meeting and interview a bunch of us. That was cool. So that when that comes out, I'm hoping a lot more of these clubs start up. And we're now in touch with the city of Amsterdam and the Dutch Defense Ministry. Again, they're like, well, we were thinking about 2028, but they're interested in supporting us. How we got here. So this is for all of you. I hope if you're thinking about starting one of these. Is mostly networking humankind. You just know a lot of people. Talks were helping. RIPE 90 Lightning talk, and I did a talk at a little open source conference near Eindhoven called TDOS. It's very cute. I recommend it. Lots of direct personal invitations. So you just have to like go out there and talk to people and say, please come to the Internet Resiliency Club. In-person meetups, you have to use Doodle. You can't just be like, hey folks, when do you think would be good? And just trying to keep it fun and pleasant. We didn't do anything like doom and gloom or competitive. So I made an actual web page with HTML that's available. I bought a mailman mailing list. It's like €5 per month. It actually works great. We have a private, unquote, Meshtastic channel. We have a Signal group chat for organizing and debugging. I'm going to make the matrix fallback, having learned Signal's dependency on AWS East 1. Oh boy. And posting on the Fediverse. So I'll tell you, if you're looking to get a bunch of people involved in decentralized mesh networking, the Fediverse is a great place to do it. So I had to front a little of my own cash money here. Frankly, deciding which LoRa node to buy and then actually buying it is the giant hurdle. This is the huge barrier that most people will not get over. So I just bought a lot of the nodes for people and fully willing to just donate them when I handed to them. But almost everyone paid me anyway, you know, Tiki culture in Amsterdam. I pay the bill at our in-person meetups for whatever's left over at the end, and I send a link to pay at through the Signal group, and I usually make a little bit of a profit. So recommend. But we need more cash money. Meshtastic in Amsterdam is fairly unreliable, but we weren't really sure why until a bunch of us went to the WHY hacker camp. And Meshtastic worked great there during their power outage. That was really fun. So we feel pretty confident. We just need more nodes, a higher density of nodes in Amsterdam to make that work. So we have those 2 grants are in progress. Part of them is to buy more nodes and give them away. Also to do some work to improve the Meshtastic ecosystem. Basically, the solution to all our Meshtastic problems is money. Money to pay people to do stuff. So I have some new hardware recommendations. The WizMesh Repeater Mini is an awesome solar-powered, ready-to-go enclosure for about €100. Tracker nodes in the shape of these thick credit cards are good for everyday carry, better than this thing. So ask Wolfgang Trammell to show you his SenseCap card tracker. I bought a T-Beam for a home station. It seems pretty good. Yeah, Wolfgang's right over there. Thank you. People are really tempted by the T-Deck, but the keyboard breaks really easily, so don't do that. In general, the hardware gets better every month. Things I wish I had done. I wish I had time to speak at NL Nog Day. Damn it. I wish I'd understood how much European governments like giving grants. I didn't realize my local cinema was funded by grants. I wish I'd asked for help organizing sooner, and I wish I'd picked a repeating monthly meetup date sooner. It felt like an obligation. Anyway, so lessons learned. Running an internet resiliency club requires about, I don't know, 1 to 2 hours per week, about 200 euros of cash to start out with, a large personal network, and frequent use of Doodle. In-person meetups are really chaotic. Don't take it personally. Sometimes there's just a few people. Sometimes you run out of chairs. Meshtastic is the worst software for mesh networks, except for all the others. So you can start an internet resiliency club too. It's worth it just to make friends. Everyone involved is super cool and neat. If you have a LoRa or Meshtastic node, please raise your hand right now. You don't have to say with you. Awesome. If you're willing to talk to other people, thank you. You might ask your employer to give LoRa radios and mobile phone power banks to interested staff members. And there's instructions and links here. Thank you.
Thank you very much. And we do have time for a couple of questions. And Wolfgang got there first.
Yeah, Wolfgang Tremmel, a Meshtastic user. Just a short remark. There are a number of communities around Europe using this device. You don't have to travel to the Netherlands. For example, in the state of Hessen in Germany, there is Hessen Mesh, so you might Google for that. In Germany, there are other users. And if your device doesn't work, check what kind of backchannel community, what kind of backchannel communication your local community uses, and ask them for configuration parameters. Some communities use a different than the standard configuration, and if you use the standard configuration, your device won't work.
I think that's a really good point. We needed to do a lot of debugging over the Signal group chat.
I didn't realize Wolfgang was so anti-traveling to the Netherlands. You know? So, please.
Peter Hessler. In previous parts of my life, I've been involved in disaster scenarios and assisting in disasters. And I'm curious how much of this work is dependent on LoRa itself and how much of it is portable to other possible communication methods like via ham or Wi-Fi mesh networks, etc.
Yeah, so the great thing about Meshtastic is low power and no license needed. And there's a web page that you can use to flash your device, right? So it just lowers the barrier and allows you to power it for much longer. And then you want to have people who are ham radio experts involved to be a bridge. So I think the technology is key. Yeah.
Okay, all right, thank you.
Yeah.
Sorry, Dmitry Kopanyuk, I may be running out of my voice since last party. Great effort. Just a quick check. You mentioned the grants. I'm not sure which source it is, and then you mentioned making a profit. I know you're not doing this for profit, but it looks like you first take somebody's money, then make. Just to understand, the devices, of course, are not that expensive, but you may need more than one per person. But do you estimate any other significant expenses for this deployment?
Yeah, so I was joking about the profit. I mean, like €5.
I suppose. You travel, sir, and then you make a profit, right? You're covering the cost of your train tickets or something.
Yeah, sorry, what was it? Could you summarize again the...
What's the other significant expenses of the hardware you could foresee for this deployment?
It's pretty much just the hardware. You can get a working setup with backup battery for like €100.
Did you include the redundant power? Because, you know, in case of the war with Russia, you probably would have that lost first.
The power bank, yep. So I have a setup that's €100 for a power bank, 15-watt solar panel, and the super cheap Heltec V3. The nice thing about it too is that stuff also powers your cell phone. So.
Yeah, not the big devices like the and stuff. Okay, thank
you. So no, one last question and then we're done. But yeah.
Crystal Visser from IIJ. So I'm also doing some internet resiliency work, but more in the Pacific focus. And one of the things we're focusing at the moment, and you kind of touched it on your slides, but I don't know if you're looking into it as much, is looking at maybe what's your service dependencies on things like outside of the Netherlands and stuff, especially for emergencies. So as you found, Signal is hosted over in the US and stuff. Obviously in the Pacific, there's a lot of places only 1 or 2 cables. But I never thought about Signal being a cutout if submarine cables are lost, but especially there because the local infrastructure could still be okay. So I don't know if that's something to maybe consider.
Yeah, so we have a local Matrix server that I have been meaning to set it up, but again, there's a giant barrier to using Matrix, so it's more like a fallback to a fallback. So we've got we're trying to get as many different ways to do it as possible. I have a domain name that's a .nl, so it's not resolving outside of the country. So yeah, we're working on that for all the failovers as well.
Okay, thanks.
Yeah.
Okay, thank you very much, Valerie. Okay. So, no, that's Dolores. Yeah, she's not trying to steal the clicker, Max. It's fine. So Right Atlas is pretty cool, and you may have seen the cool visualizations. And now Stephen's going to tell us all about Kipu, and and what's going to be awesome from the point of view of visualizing more Right Atlas stuff. Please.
Great, thanks. Everyone hear me okay? Great. So I'm Stefan. I'm the UX, UI, front-end visualization guy for Atlas. So everything that's related to all that, that's me. Here I want to talk to you today about Kipu, which is our new visualization, primarily for trace routes, but also for DNS and ping. It works. So we had this idea a few months ago that it was really difficult to work with large measurements that contained many hundreds and sometimes thousands of trace routes, and to really have a visualization which allowed you to compare and filter and look at things in a simple way. So that was the sort of impetus for creating Kipu. We've called it Kipu because it resembles the Incan recording systems, this accounting systems that they would use in South America to keep track of things. We think it bears a visual resemblance to that. So its use cases include detecting outages, troubleshooting latency, validating routing paths, checking DNS resolution, or looking at the answers or responses, filtering IXPs, and a lot more. So the key features of Kipu, like I said, it works for traceroute primarily. This is really its primary use case, but it also works quite nicely for DNS, although it's a simpler visualization, and for ping. Within the traceroute views, we have several visualization modes. The main one is the IP view, and there you see really detailed hop-by-hop analysis with individual IP addresses. And in the IP view, you have either hops or RTT distance mode. If you're looking at hops mode, really you get a sense of very quickly visually of which are the paths that have the greatest number of hops. And if you switch to RTT view, you can really tell quickly, which is the one that has the greatest latency. I should say that in RTT distance mode, we also, sometimes we have anomalies on various points where, let's say, the node has an RTT which is greater than the last hop at the target. So we note these and mark them on the visualization so they're easy to identify. Then you could flip over to ASN view and really get a network level topology showing your AS paths and IXP interconnections. This is really great for checking if your routing is working the way you think it is, if your paths are actually the trace routes are following the paths that you expect. And then finally, there's a country view that shows a similar kind of visualization, but trying to mark the paths through various countries. It's currently derived from a combination of ASN registry information, IXP information, and IP locate cache. As you probably all know, IP location is an extremely difficult and complex thing to do. So we don't guarantee that it's perfectly accurate, but we think it still has a use case and it's still useful for kind of just doing a quick sanity check. We have two main layout modes. The main one, which is this radial view, and is the default, but we also have a horizontal view. I think you'll find that depending on the measurement type, the number of trace routes, the complexity of it, that one view or another might be better to use in a particular case. There are a lot of interactive capabilities with Kipu. So real-time panning, zooming, node selection, it's all very high performance. It's very rapid and quick to use. It's very responsive. We have various toggles depending on your view. So if you toggle the successful toggle, for instance, you could filter out all of the trace routes that were successfully made it to their target, and just see the ones that failed. So you could really isolate just the failures in a particular group of trace routes. You could also toggle on or off the target, showing a little info window for that. If you're looking at the traceroute visualization, mostly the source nodes are all at the outside, and they're labeled with a little flag for their country and the IP address of those probes. But you can actually toggle that so it just shows the probe ID instead of the IP address. And then you can also toggle labels in ASN view or IP view or country view to actually see the information around each intermediate node, each intermediate hop along the way. We have pretty nice hover pop-ups where if you're hovering over any particular node, in particular, let's say the source nodes, which are the probes, you'll see a little pop-up window like this, which shows you your whole trace route. If you click on the probe ID, it'll take you to the Atlas probe detail page. If you click on any of the IP addresses, it'll take you to RIPE-STAT to give you information about that IP. And if you click on any of the ASNs, it will also take you to RIPE-STAT for information about those ASNs. There's also a little copy button there. If you click on it, you can just very quickly copy all the information in the particular pop-up and paste it into an email or whatever communication. And finally, it's quite useful that as you've filtered all of these various things within Kipu to really get your view to the way you want it to be, all of the links can just be copy and pasted from the URL to someone else, and they will see exactly the filtering that you see. I should also say a little bit more about the filtering itself. There's a pop down for country filtering, so you could just select the countries that you want to see, and this will filter out probes that don't fall into those countries. There's also a slider for RTT ranges so that you can say, oh, I only want to see the probes that are between, let's say they have a greater RTT than 50 or 100 or something. Talking a little bit about under the hood, there's a lot of data enrichment going on. We are enriching the data with ASN information, IXP information, country information, reverse DNS lookup, Anycast target identification, and we also support multiple targets. It's interesting that if you put in a measurement domain instead of an IP address, many of you know this, some don't, that when you make a measurement like that within Atlas, each probe will actually resolve the IP itself. So if you have a target, let's say store.apple.com, and each probe will actually resolve that. And so that might mean that you have many, many targets for a particular measurement set. And in Kipu, you actually can see multiple targets in the visualization. Quick overview of the technical foundation. It's built with Vue, the same framework as the rest of the Atlas front end. We have these pre-built data caches for IP to ASN, which comes from RIS Whois, IXP information, which we get from PeeringDB, ASN to country information, which is all delegated stats from the RIRs, and an IP to country, which is using IP locate database for not super accurate, but kind of accurate country location. And these are all built once a week, and it's about 15 megabytes or so of compressed data. So once a week, Kipu will download that to your local storage and use that local cache to do its lookup. So instead of any particular visualization taking thousands and thousands of API calls, everything is looked up locally, which makes it very responsive and very quick. D3 we're using for the data processing and the hierarchical layouts, and WebGL for high performance rendering, because it really enables a much smoother interaction. I originally started building this with SVG, and after about 100 trace routes, it became unusable. So changing it to WebGL really bumped it up and made it quite responsive. So the combination of the caching and the WebGL really has quite high performance even for hundreds or thousands of nodes. There are resources that you can look up. You can take a look at the docs. You can take a look at these labs articles. The earlier one that's talking about the prototype goes through the sort of initial reasons for Kipu and how to use it. The docs are pretty in-depth, and then the labs article was just released last week, which gives you 6 use cases for Kipu. This is supposed to be an animation playing, but it doesn't seem to for some reason. So if you would like a demo later, I'm happy to give demos and encourage you all to try it out. And if you have any questions about it or feature requests, please contact us on the Atlas team. Thank you very much.
We have time for one quick question.
Peter Hessler, at a previous job, I was running a global Anycast cluster, and you mentioned you have multi-target support, and that sort of thing would have been very, very interesting to me at that job. Does your tooling support the multi-target for detecting Anycast DNS clusters, for example?
No, it doesn't do that. When I'm talking about our multi-targets, it's really where each probe is resolved to, and we're taking those IPs that the individual probes are resolving to and putting multiple target points. But if I'm understanding you correctly, and I had a question similar to that earlier in the week, and yeah, something we need to look into. Sorry.
Okay, yeah, because like you can easily do like a bind.host name lookup and then match those together, because that would be the encoding of the location. So that when you can say, for the Anycast cluster in X location versus Y location, and then make those understandings based on that.
Yeah,
that'd
be great.
That would be wonderful to see.
Thank you.
Okay, thank you very much, Stephen.
Thank you.
Next on, we have Erik van Wooten, who's going to tell us about measuring something using TR-471.
Good morning to you all, and I'm really great that I may do my presentation here for this audience. Let's start where we want to talk about. It's more or less speed and how to prove speed, because we had it several times, and if you look to what's happening in Europe, that we are delivering more and more speed. I had yesterday a chat with some guy from Swiss. Yeah, I already have 25 gig at home. Yeah, that's interesting. But how to prove that you have those speeds? And that becomes more and more a problem, because we can't use the hardware. If you look to the common user at home, they don't have a sophisticated hardware to prove those speeds because of bad Wi-Fi. The cabling system might be not so accurate if you expected. And last but not all is the whole NIC. The network interface is not really can handle all those speeds. So just to prove link speed, we have to do for something else. In this case, get rid of the whole internal stuff. Even local authorities are pushing their customers to do some tricky things on their networks, and so they can show, yes, I can reach my promised speed from the internet operator. So if you look to the German, this is from Germany, Breitbandmessung, it all related on a PC. So you run an app on the PC, and then yes, I reach my speed. This is fine when you have, let's say, 100 meg. The average speed you see in a lot of parts of Germany. But if you compare this in other countries who run above 4 gig of speeds, you can't use those tools. They're far, you can't reach all those speeds. So we have to do something else. What's the solution? The solution is, first of all, we want to use UDP. We use UDP for those tests, and in this case, the Open Broadband UDP ST is something you can find on GitHub, so you can build it by yourself, very easy. And this just runs a very simple method. It's not so complicated. It's a sender. It sends out a message to the other side, in this case, a CPE. You can prove the download, you can prove the upload, and do all the measurements with jitter and what type of speed can reach, and so on and so on. So, from my point of view, maybe I'm a little bit too optimistic. It's quite easy. But again, then the Open Broadband UDP-ST has to run into the broadband form. The broadband form is running on standards. In this case, we use the standard TR-471. That's more or less the broadband form name of the whole Open Broadband UDP-ST. Sorry for the long words. AVM nowadays called Fritz, is member of the broadband forum, and we find this very important to run this. So we run this on our CPEs, the modern CPEs. And again, be aware you're running a speed test, so it depends on the SOC you're using in your CPE. All the ones can have a problem by running those tests. But anyway, from my point of view, this is important because, as already said, more and more local governments are pushing their customers that they check the speed they ordered at their internet provider. In the past, we had some other methods to do this. This runs on TCP. And as you all were known for those type of tests, it's a little bit complicated because the performance related to the SOC might really be a problem. That's why the whole industry is moving more and more from the TCP for run those tests to the UDP standards. Very proud. This is my really first AI generated picture. Never did this because I'm not an AI, but I managed. And in fact, this is the whole picture. This is it. As said, not so complicated, but from my point of view, very important to do this. Most of the things already mentioned. So in case of time, I will a little bit speed up. But the last sentence, from my point of view, one of the most important ones. We run our networks and we deliver our speeds to our private customers higher and higher and higher. 10 gig is not so unusable anymore. As said, in Switzerland, they run 25 gig, and we had last week at Network X, we discussed already the 50 gig. So 50 gig delivery to the end customers in the European market. So this will be more and more relevant to show and to check, okay, is it still the speed what I requested, is it still possible to reach those high speeds? How this works, some text, I see it's way too small to read it, but it's just a few sentences. You have to plug it in your USB controller. The USB controller can automatically do those tests. Just make it very easy. I hope you use USB and not TR69 because this is legacy stuff. So please move to USB. And this is what it brings. So it gives you a very clear overview. And this is just an VDSL line at my office, so don't be surprised about the speeds. But it promises and it shows you more or less everything you want. Up, download, litter delays, and so on and so on. So last thing is go forward, use it, test it, and make it possible. Thank you.
Okay, thank you very much. We do have some questions.
Tom Strix, Cloudflare. I'm kind of wondering, this is only validating speed within the ISP's network, right?
It is validating speed between the server, so this case the content server, and where it's located. So most cases, yes, within the ISP, and the CPE, this part. As you probably all know, within the broadband farm, they're running things, and it was also mentioned here as well, that we go to the end-to-end solution. But this is not covering the end-to-end solution. It's between the ISP network and the CPE.
Okay, thank you for that explanation.
Yeah. Any other? Nothing online? Nope. Okay, thank you very much, Eric. So, this is the first ending of a number of endings today. That is the end of the submitted plenary content, and we now move to the end of meeting reports. And first up, I'm going to ask Francisca to give the report from the Code of Conduct team, please.
Hi, everyone. So as you are by now accustomed to, I will give you our transparency report since RIPE 90. This is a very short presentation, so I will skip all the what is the Code of Conduct team. You can find all of this in the newcomers presentation and also in the opening. Let's dive into it. So what have we been doing since RIPE 19 and what has roughly taken place? Since RIPE 90, we received 4 different reports, but they related to 2 distinct incidences, so multiple instances of the same thing. Of things. We could successfully conclude one report. We deemed it was indeed a violation of the code of conduct and we applied consequences. We try to give you rough categories of what kind of incidents happen so that you have a feeling what is going on in the community, but obviously due to confidentiality concerns, we can't divulge details. In this case, there were instances on multiple mailing lists on very strongly insulting communication. Okay, my screen is, there's my screen. And we decided that this warranted a ban for 3 months from the relevant mailing list from the code of conduct side. In the aftermath, in case you were confused, this was handed over to the working group chairs in case they wanted to deal with this further in their respective lists and positions. Since RIPE 91, we had 1 new report received via email. We formed an assessment groups, team members who had a conflict of interest, recused themselves, and we contacted both parties. We ask you your understanding that for the cases that we are still evaluating, we can't give categories or details yet, because that may or may not influence how we can handle this case, and this is something we are very aware of. Very, very dear to us. I know we report this every time, but you can report to us if you experience in whichever shape or form behavior that makes you feel uncomfortable. You can just come and talk to us. I would very much like to highlight that if you are not sure if this is worth reporting, you can always report it and we will evaluate whether we deem it a code of conduct violation or not. You reporting to us does not automatically mean an outcome. This is our responsibility, not yours. And obviously you can always come find us, talk to us off the record if you have any questions and want to know anything about what we are doing or maybe about your specific case or someone you know about. In general, you can reach the whole team by the form, the reporting form that is linked on the respective meeting website and also on the RIPE website. You can reach us under conductreport@ripe.net. And of course, individual team members are around. You can find our faces on the page of the Code of Conduct team. We have it all on our badges. And in the opening plenary and also in the newcomers presentation, we are presented. So you should be able to find at least one of us and then we can deal with it further. Otherwise, we all also have dedicated email addresses if you, for one or other reason, only want to contact individual team members. If you want more details, ripe.net/COC is there for you and it should have everything. Other than report handling, what have we been up to since last time? We had 2 new members joining, which is great. Because that gives us more diverse perspectives, more opportunities for load sharing. So in case you are also interested, reach out to us or to the chair team. We had a RIPE Labs article published. I think many of you already saw this because we are doing a survey. On a serious note, we were slightly concerned that we don't get a good picture of what is actually happening. I mean, it's great. We don't receive that many reports and either we all angels here or something else is not exactly going how it should be. But please go fill this out. Give us your honest feedback because we want to know what we can improve for the process, what we may still need to learn because this is very much a learning journey. So far, we had more than 50 replies, which we actually considered reasonably good. Survey closes end of October. And on top of that, we are working on a list of frequently asked questions that we can just compile based on our experience so people have a very low barrier way to understand a little bit better what we are doing. And again, this is our team. These are my excellent colleagues. Not many of us already needed to leave, but you can still join us. So reach out to the chair team and to us. Questions?
Peter Hessler, longtime fan of the Code of Conduct team and the activities you've been doing. I would like to encourage the community to keep in mind that the Code of Conduct team is here to help you have a good time and to assist with us being professionals and enjoyment for everyone who attends here. So anything that you're even unsure about, please go talk to the Code of Conduct team and bring it up to them. We want to hopefully end any whisper networks that have been happening and actually address whatever issues this community may have been having. Thanks.
Thank you. Couldn't have said that better.
Do we have any online? No, we don't have any other questions. So thank you very much, Franziska. So now the presentation that we're all waiting for from Short, but the technical report from the meeting. We've been waiting a long time, so please, Short.
Hello, everyone. My name is Sjoerd Oostdijk. Unless you're Dutch, you can't pronounce it, so, you know, usually people don't even try. As you all know, we've been here before, so I thought I would give the technical report a little bit of a twist and show you some of the differences that we've been going through over the past 10 years. This is what it used to look like. Someone pressing buttons. That was Val. Thank you, Val. As you can see, that's Menno there on the floor. It's not very clear on the LED wall, but I think he's wearing the same clothes. So, I don't know, he might have been time traveling. And as it was pointed out, on the left, that's Colin. And on the right, that's Marco. They look the same, but you can tell them apart from blue and orange, right? That's the only difference. And we now need 6 people, apparently, to install things. Who these other people are, they were just there. No, actually, they were installing one of the fibers. This was last Thursday. So it was a bit last minute, but fiber came online and it just worked. This is the hallway. I mean, spot the differences. I think that monitor in the wall is just the same monitor. They just slapped like a metal plate in front of it and called it a day. Main differences are the door is now closed and there's chairs next to the little table and there's a guy on a laptop. Oh, I don't know what this is. I mean, somebody's been messing with my slides, I guess. I suppose I won't mention it for fear of my own life. But yeah, some of these things have changed since the last 10 years. Terminal room is no longer terminal, it's just a workspace. We've been working with Meet Echo, I actually don't know how long, but we used to do it ourselves on a thing called a NewTek TriCaster. Arrow hives turned into ubiquities. We'll get to that in a sec. A gig turned into 10 gig, but as it turns out, we don't need it. We'll get to that in a sec as well. And we're doing widescreen now, which is very advanced. And we're doing IPv6 mostly, which is mostly the work of Andre, but we'll get to that in a sec as well. So we already had 2 redundant fibers back then. Now we have a 10 gig and a 1 gig. So I know I had to put my artwork up here because it's just that good. So traffic is more, not that much more. It went from 120 Mbit to 200. So, you know, all this Insta doom scrolling is not really making a dent. That's just assuming that the M in this MRTG graph is actually M bits. But yeah, these are the access points. So square access points are back. They were in the side room now. Next time, I hope to have some more, and it's actually a lot less work. So if you can look at this map, we used to have 18 access points in this room alone. Today we have 8, and next time it'll be 3. And we used to have 12 in the side room, and it should be 2 next time. So it's a heck of a lot less work for us. Actually, associations on the Wi-Fi have gone down for some reason. We were talking about it. It's gone from 1,000 to 700-ish. I think it's just Europeans not bothering to put their phone on the Wi-Fi anymore, because 5G is a thing and roaming is a thing. So I like Europe because of that. We had music again at the beginning of the week until it drove people crazy, and it also had some issues. The whole intent was for the web team to be able to tell when the session started, because the chairs would have to ask, hey, can you turn off the music? But yeah, like we had 2 songs in our playlist, and we sort of stopped doing it after a while. I mean, you know, just to keep sanity. The other thing is, I'm sure we've talked about this in the past. Like, I have a monitor here showing like notes and stuff. We also have an HDMI cable over here if you want to plug in your own laptop, and that's been running on little boxes that do HDMI over Cat5 cable, not IP, just the cable, just the copper. And it gave us a massive headache this time around. I don't know, I think there's interference. They're going like along the wall to the back corner there. But they just, one of them worked fine, the other one just didn't. We redid the cable, nothing helped. So we tried the same box, but it uses IP, and that ran into HDCP, which is the bane of my existence, which is high definition copy protection or something. It's a piece of shit. But luckily on Ali you can get splitters, HDMI splitters that remove HDCP. They're our friend. We have many of them. We have convinced many other people to get the same ones. They're great. Next thing is actually IPv6 network was taken into production on RIPE 71. It was requested at 66, but we didn't feel like doing it right then and there on the spot because it was too experimental. On 67, we introduced the experimental SSID, and on 71, we called it production and, you know, gave it to the world. So these graphs just look the same. They're actually completely unrelated, but since they look so similar, they would made sense to put them on the same slide. Top one is the legacy SSID today, which is like if you have trouble with your device because of reasons. Yes, I see you nodding. You can go on there and your problems might go away. The bottom one was actually the NOT64 one at RIPE 71. So I think the tables are turned now, finally, 10 years on. I mean, it's taken a while, but it's getting there. Legacy is replacing what used to be 6.4. Of course, we couldn't have done it without all of the good people doing all of the technical things. Meet Echo team, the Steno team, and of course, the tech team. They're all hiding in the corner over there. So I'd like to ask you to give him a big round of applause. Yeah.
So awesome stuff as always. Please.
John Linkova, thank you very much. You said that 2 graphs on slide 13 are not related. I actually think they are. You basically showing, first of all, that it took RIPE NOC 10 years to declare IPv4 legacy, right? It's actually the same graph.
Which is faster than most people.
Neil O'Reilly. I have to put my hand up as one of the long tail of legacy users, but I'm planning to upgrade my phone before Edinburgh.
Excellent. There's 10 people on there or so that's a good chunk.
There's going to be someone who's just going to stay on just to be the last.
Yeah. Who will be last?
Vladislav Velikov. So I have a theory why your HDMI over Ethernet doesn't work as someone running a faculty with a lot of those cables. Either one of the power supplies malfunctioning or the sender and receiver are on the different phase power, and this creates the blinking thing. It's not the cable.
Okay. Well, we're going to get, because our audio guy had HDMI over fiber cables, which worked great. By no coincidence, he's a reseller. So, we might look into them.
Jim.
Jim Reed. Sure, I just want to say thanks to you and your colleagues for all the amazing work you do to bring up this network. The network's been rock solid this week, as it has, pretty much every right meeting. And there's a huge amount of work goes on behind the scenes to make that reality. So I'm very, very grateful to you and your colleagues for making this happen so smoothly. You do a fantastic job. And also, because of the fact that infrastructure is so stable and reliable, it makes the job of the others who help and facilitate things, the MeetEcho team and the stenographers, they get an easier time of it as well. So thank you to everybody for this. We couldn't have these meetings without you. Thank you.
Thanks, Jim.
Andrei Robachevsky. Hi, Shoot. Well, congratulations and thank you to the team with great job. And as you mentioned, there is a lot of progress, but also many similarities. But this spike on Tuesday, at the same time almost, have you investigated what was going on?
No.
It is amazing. I mean, the profile of traffic is the same, but the spike, if you could roll back to the slide and just...
This one.
Was no. Was a specific presentation the same? Maybe update on the same thing? Anyway, thank you.
Okay, one last one.
Tom, a massive fan of statistics. Can we get a public dashboard during the RIPE meeting that we can just kind of look at things, and then you get people doing competition? You might actually get a full use of the 10 gig if you show people, it's like, you're only using 200 meg, please use more of it. The easiest way of doing that is just showing us a Grafana dashboard.
So those new access points are also on 2.5 gig. So we'll have hopefully like 5 or so out there next meeting. So if we coordinate things, we might get to 10 gig.
Excellent, thank you.
Okay, go on.
Very brief comment on that. So Peter Hessler, wearing my hat from the CCC Congress, we have a public dashboard. People do interesting things with our traffic graphs. So there be dragons.
Okay.
Anything online? No. Okay, thank you very, very much, and to all of the people involved. Okay, and now the program committee are done. Do you want to say something? Or no? Okay, good. So thank you to everyone who submitted content for us this week. The call for papers submissions will be open relatively soon. Again, 2 weeks. And now we will hand back to Miriam. Thank you.
Thank you. Thanks for running this last plenary this morning on Friday morning. Really interesting presentations. Yeah, we're almost at the end. Just a few more announcements and thanking people. Yeah, this is the statistics I showed you earlier on Monday, but now these are the final numbers. We had actually 665 people checked in the end, both on site and online, which is great. And I'm always pleased to see so many people from so many countries actually represented here, 47 countries this time, and also a lot of newcomers on site. Again, you heard a presentation here, but I would like to thank the Code of Conduct team once more for their really important work that they're doing behind the scenes, and they're available for you. And please, yeah, as Franziska said, please don't hesitate to go and report and don't go like, well, maybe it's not so serious, but just they know how to handle this. Some more announcements. The NRO Numbers Council elections were going on during this week. These are the result. This is the result. Constanze Bürger was elected again for another term on the Numbers Council. So congratulations, Constanze. And of course, also thanks for all the other candidates who were running and make this a proper election, actually. Some announcements on changes in working groups. Also, there are some outgoing working group chairs. Willem Torup is leaving the DNS working group as a co-chair. Willem, are you here? Come here. Come over. Yeah, you come over. Just a little sign of appreciation for your service as DNS co-chair for a while. I don't know where the gift is, but thank you. I think they're all in the back there. So. Thanks, Willem. And we also had Nikos Chotelius from the IPv6 working group. Thanks, Willem. Has stepped down from the V6 working group in between the meetings, and has been replaced. We'll come to that with somebody else. And then Rob Evans in the NCC Services working group, his term ended, and he is running again and has been selected again in the NCC Services working group. As you can see here, his picture hasn't changed. So the other two, so Ulrich has been selected in DNS to take over from Willem. And then Wolfgang Tremmel has been added to the co-chairs for the IPv6 working group together with Raymond and Christian. So welcome to the team. They already participated this week also in the meeting that we usually have with the working group chairs, so they're kind of onboarded already. This is thereby the new kind of, page with all the working group chairs. You can find more information about each working group and their selection procedures, as we have discussed yesterday, on the website. Right. And big thanks again to the RIPE 91 Program Committee who put together the plenary part of the meeting. So thanks for your great work during the week, and also to I know there's a lot of work going on in the background to make sure people are showing up on time, and make sure we have right session chairs in place and so forth. So well done. Thank you all. And a special thanks to Franziska and Valerie. I believe you're both in the room. Could I ask you to come up and give you a little gift back as well? They're stepping down from the PC, as Brian has already announced, but I want to just put them, give another round of thanks to them as well. So thanks, Valerie. And these are the two new members on the PC, as Brian has already announced. So if we put a picture here as well, so you know how to find them, they'll start working with the rest of the team soon after we open the call for presentations for RIPE 92. More thanks. I would like to thank not only the tech team, but the entire RIPE NCC staff, and especially the events team who are here. Kajal, over there in the back. I just wanted to thank you. She never wants to come up on stage, so it's okay. And also the other events team members who were behind the registration desk and were helping out during the week, and everyone else who was here in the background helping out. And then last but not least, I'd like to thank the host, Interland. Do you want to come up for... Thank you. Yeah, we're not going to do that again. I knew this was going to happen. It's okay, we're almost done for the week. Thank you. And then, of course, we would also like to thank AWS for their, sponsor as platinum sponsorship. Again, I don't know if anyone is here taking a plaque. Is Clara still here? Yeah, there you are. So thanks for your long-term support for the RIPE meeting, not only individually, but also with your AWS hat on. And of course, thanks to all the other sponsors here as well that have supported us. And last but not least, as another reminder, please rate the talks. I know yesterday we heard some feedback and that it's maybe could make it a little easier to actually go in the system and rate the talks, so we'll look into that. But in the meantime, we'd still like you to give us your feedback and feedback in general. Also, the RIPE NCC has set up a survey and a feedback form that we would like you to fill in. If you have anything to contribute, tell us if you liked it or if there's anything we could improve. We would really like to hear from you on that. And last but not least, this is the next RIPE meeting in Edinburgh, RIPE 92, not 1992. And registration is open, the website is open, you can go in there. You can maybe become #1 registrant of RIPE 92. No, it's already gone. Oh, #1. I said you again? Oh, okay. Well, some people are fast. Great. It's great to see we already have 3 registrations. And so by that, I would actually like to ask Linda, there you are, come up who will be the host for our meeting in Edinburgh to give us a quick introduction and encourage you all to come to Edinburgh. So that's all from me. Thank you. Have a good trip home. See you next time.
Hi everyone, I'm Linda Shannon from Hilco's IPv4.global, and we're so excited to invite you to Bonnie, Scotland for RIPE 92. Edinburgh has a long tradition of engineering, from building the great bridges of the 19th century to the steam engine to advancing the networks that connect us all today. It's mix of rich history, innovation, and a vibrant tech scene make it the perfect place to bring the community back together in May. Just briefly about us, your next local hosts. Hilco Global is a diversified financial services company. We have over 800 employees operating across 4 continents, including our Scottish office. I think many of you might be most familiar with our intellectual property and our IPv4.global practice areas. We operate a leading brokerage, helping clients to navigate the transfer markets and to lease addresses and raise capital against IP assets. We also provide world-class IPAM and DDI software with our recent acquisition and relaunch of Provision built by 6Connect. We've sponsored RIPE meetings for many years, and we support other events in the community, such as Net UK and Links events in the UK. Our European team has been out and about this week, and we've more than likely at some point given you a CIDR cider glass or poured you a drink at the Whiskey Boff, which we'll have to make extra special in the home of Scotch whisky. Edinburgh's a really beautiful city and a UNESCO World Heritage Site. It's really walkable and compact. In your spare time, you could hike up Arthur's Seat, an inactive volcano right in the heart of the city with amazing views. Or of course, you could visit Edinburgh Castle. If you stay on, if you've got time, which I'd really encourage you to do, it's so worth exploring other parts of Scotland. You could take a trip out west to Glasgow, where I'm from, a city known for its architecture, its music scene, and its friendly folk. You'll definitely make a new pal quickly. St Andrews, the home of golf, and the university town at the seaside is also not too far. On the west coast, Loch Lomond is lovely, and you could head on up to scenic Glencoe and even the Isle of Skye, or so much more. So how should you prepare? Kilts are obviously highly encouraged. It's traditional not to wear anything under them, but we might need to consult with the Code of Conduct team on that one. Contrary to the stereotype, Edinburgh receives less rainfall than the rest of Scotland. Maybe just bring your umbrella to be on the safe side, although we do hope for pleasant weather and long nights in May. Please check if you need a visa, check that early. Note that EU nationals and others might need to get an electronic travel authorization. You do that online. It's usually pretty quick, at most 3 days. Edinburgh is very well connected. There's direct flights to very many parts of the service region. There's also a direct train up from London, takes about 4.5 hours, or you could try to walk 500 miles like the Proclaimers song goes. Yeah, so I mean, overall, it's just a really welcoming and inclusive and diverse country. And, you know, we really can't wait to extend famous Scottish hospitality to you. And we'd absolutely love to see you in Scotland next year. So, yeah, any questions in the meantime, like, please, any recommendations that you'd like, please don't hesitate to reach out to me or, yeah, any member of our team, and see you there. Cheers.
Andre, I see. So when are you joining EU again?
I mean, I'd lobby for it. I know, such a shame.
Jim Reid, just in response to what Andre said, some of us felt we have never left the EU. One more thing, Linda, thanks for that very good introduction for the upcoming meeting, but so another few words of advice for everybody here. If in the unlikely event you have any difficulty at the border with the immigration people, just remember these 6 words. That ball never crossed the line.
Thanks, Jim. Okay, cheers.
No other questions or comments. Thanks, Linda. Looking forward to the meeting. Yeah, that ends my show. I don't know what's going on here behind the scenes, but.
Let's see if this works. Hi, everybody. Welcome to the Groupe de Lucru Secret of RIPE 71. I was hoping I was going to grow my hair back but when I was going back in time. I guess that didn't work. Oh, tough. Okay. Well, in that case, let's just go widescreen, as Sjoerd said. The secret working group of RIPE 91. with more bling and more LEDs and more bright lights and other things that I can't quite explain. I have no idea. I think I've been to this place in San Francisco. So, to those of you who don't know what the secret working group is, it's a secret. It's kind of in the name. What is its secret? What does that mean? It means no pictures. Hi, gentlemen with the camera pointing at me. It means no text messages. It means no Facebook, no Telegram, no Twitter, no YouTube, no Instagram, no TikTok, no WhatsApp, and also no why. What is why? I don't know. I don't know why. So on to this week's events. Oh, what a feeling. As the Lionel Richie song goes, dancing on the ceiling. And Lionel Richie would have been proud of this week. So here goes. At Ripe 91's Tuesday night bash, we nibbled and sipped in a flash. Then up from the ceiling came flips that were reeling while we ducked when they nearly hit our glass. And it was lovely entertainment. It was very well done. Compliments to the performance. However, same as with the Lionel Richie song from the 80s, I'm sure you all remember, there is a bit of a saturation point. So when last night at the dinner, it was another lovely performance. But maybe, I guess the organizers got a discount for volume. I don't know. But there was another thing about Tuesday, and I think Jan's going to be talking about that as a resident expert. Hopeless and hapless.
At the Ripe 91 Tuesday night scene, cocktails, wine, and soft drink were seen. But beer was amiss. Some frowned at that bliss and muttered, "No hops, this is so obscene."
I honestly thought I'd never see the day of a beer-free social at a Ripe meeting. It's a miracle we're still here and that more people haven't melted, because they previously assured me that they would. All right, then on to a thing that's closer to the heart of the secret working group. There's a lot of stuff from the secret working group, especially from the olden days, in the Ripe database. Limericks from the secret working group end up in the Ripe database. There's a specific type of object in the database that describes this, and every decade or so, some academic researcher shows up and says, "What the hell is this stuff? Why is it there and shouldn't it be deleted?" And then, of course, those people get very swiftly dealt with. But there's a problem that is neatly described in this one. Jan, you wanted to do this one, right? You sure? Okay. The database breakdown.
The year is 2025. Alas, there's no more MD5. But the poems survive. For now we will still scribe sweet sonnets in quiet dedication.
We can't submit anonymous poetic objects to the database anymore because we've gone too secure. And some may consider this to be a feature. We think it's a bug. So about that Ripe time loop. We're obviously back in Ripe 71. The hair didn't grow back, but and this is something obviously the ops team found while they were building up in the basement. And as people who have ever built up conferences before, they know that basements of conference hotels are the stores of uncountable lost valuable items. I mean, if someone needs to find the Ark of the Covenant somewhere, it is probably in the basement of a hotel somewhere. And there was another thing, because we decided to have a look ourselves. There's another thing that I found in the basement, and which I found intriguing, and which confirms the right time loop again, which was this thing. And I thought it was rather special. It was more sparkling than the Ripe 91 one. I mean, I'm sure AI was all over it. So I mean, I tried to get it up here to put it on stage, but I mean, it vanished as soon as I touched it. So I mean, there's something still going on there. But I did find a USB stick of sorts, and there was a couple of like the short like PowerPoint-y kind of. It was a file format that I could still open with my legacy software. And there was one slide that I would like to share with you. This is the overview of the lightning talks for November 17, 2033. So if your name is on this slide, or you know any of these people actually exist, my sympathy. But to give you an idea of what we will be talking about 8 years from now. There's quantum safe routing experiments at SurfNet. I don't know if SurfNet's aware of this yet, but better get that into your strategy. There's IPv6 segment routing and IoT meshes. I mean, I'm sure LoRa one also plays a role in that. Then we have edge peering for AI inference workloads by Google Edge Infra. Sounds like a reasonable topic. And then we have self-healing optical networks. And then my favorite topic, which I think should be actually in the next RIPE meeting already, the ethics of routing decisions. So, back from hallucinations. An unsung consensus, a sonnet. There's always a sonnet during a secret working group, and it's really not a sonnet. It's a sonnet-ish. Nigel would not approve, for the people who know who Nigel is. Yet here we go. A little bit of background. Unsung consensus. This is about someone who's been unassuming, mostly operating in the background of RIPE meetings for many, 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 many years, and speaks and understands quite a few more languages than you think, which is, I mean, the speaking is one thing, the understanding might be of more concern to people trying to have a quiet hallway conversation. But as we say in the secret working group, game knows game, so we appreciate you. And we see what you're doing. And this is actually about the only person in the room who could possibly read this sonnet. But we're not going to let him. Of course, about our outgoing vice chair, Neil. So, Neil, this one's for you. And yeah, so I recruited some help because there's absolutely nothing that we could possibly, I couldn't possibly read half of this. So we'll take turns. We have mostly native speakers for all of this stuff-ish. So here we go.
A gentle hand upon the tiller set.
Il tocco leggero porta grande aiuto.
Je zachte kracht heeft alles stilgestuurd.
Krvmaga tagaskachole chlis.
Pour les accords, il n'y a pas de crise.
The groundwork laid where policy is spun.
Nu eindigt deze taak, na al die tijd.
La comunità non ti ha mai dimenticato.
Is de duchrach vonnische fjord.
We offer thanks for all the deeds you did.
Au revoir, monsieur. Avec notre grand respect.
We danken je voor alles, met een lach.
Jartus agus Cora, he got real.
Now, see if I get this right. Kappa! Buffalo, yeah!
I have a final duty before we go home. But first, I want to thank this secret working group for a lovely surprise. But I've partially executed this duty, so some of you will hear another time. But now that we're all together in the one room, Nigel charged me to give his regards to, wait for it, anyone who still remembers him.
Right. Well, that was something. Then on to other important aspects of this meeting. Coffee, of course. And with exciting new coffee options. Soy, oat, coconut, or ink? I don't know. There once was a bold barista whose latte art skills grew lista. With a printer so neat, they'd logo your treat, and now my cappuccino's a vista. I appreciate it. I'm sure that we can find some better quality artwork. Getting confronted with an I Heart IPv6 first thing in the morning is probably not what I need at that point of the day. Maybe a double espresso, that is probably a better fit. Then on to other things. This is a topic we've covered before. It is the 64:9 aspect ratio. And if you don't know what I'm referring to, this meeting room is 64 seats wide by 9 rows deep. Count it, I did. So in terms of the AV geeks, I think the proper name for this is ultra widescreen. So here we go. A meeting room, ultra wide, had 3 different time zones inside. If you sat in the west, well, the east was addressed. By the front, next day's meeting applied. So if we're doing ultra widescreen, and then again the AV geeks would know, a flat ultra widescreen is not a great viewing experience. So our request to the meeting team for next time, if we're going to have a format like this again, let's go curved, maybe. So if your meeting room screen's ultra wide, go curved. Keep your eyes on the right, for flat makes you twist and have to just as missed, while curved keeps your focus inside. And whether it should curve outward for the speaker or inward for the audience, I don't know yet, but that's for the meeting team to figure out. Then, we had something else here this week. There's a BOF of some renown that happens on a Wednesday night. Then there's now another BOF with lesser renown that also happens on a Wednesday night. So let's do a bit of a side-by-side, shall we? So a tale of 2 BOFs, if you will. So there's one that starts, fashionably late. Can be smelled from a distance, certainly if it's been going on for more than an hour. Has standing room, and if you're lucky, clean glass. Has definitely a bring your own policy since its inception. next morning exists as a concept, and it's definitely not everyone's cup of tea. The other one, however, starts at a very sensible time, has no distinct odor, has comfy chairs and board games, has limited included supplies. Your next morning is fresh and pain-free, and is literally a cup of tea. So, side by side, your choices for this meeting and possibly the next one, the whiskey boff and the tea and board games boff. And yes, right. And then we had a lovely presentation by Ilke from the RIPE NCC. If you missed it, it was amazing, and you should look up the slides and her presentation. It was a history of the RIPE documents. And she had some amazing slides, so I'll just show some of the content here. She did the absolutely thankless job of trying to figure out how all of this aligned up together. I mean, I have to commend her for doing this. This has been probably one of the most thankless tasks since the ancient Greeks. So this was her sort of tree of what kind of documents we have. This is only for one series of documents. This is sort of the coloring scheme of all of the RIPE documents and roughly what category they fit in, including, I think one was like RIPE 8, the RIPE 80 document was hotel recommendations in the Amsterdam area, something. So here's one for Ilke.
Of RIPEs, 800s and more, a mountain of records to pour, with categories wide, where logic did hide, the pile was a mess to explore.
And Ilke, I mean you no ill, but I was reminded of this picture when you were doing your presentation.
At least for us, it feels like this. But I need to correct you. It wasn't thankless. She has been very much appreciated by everyone, and I really hope you recover from this.
Rate the talks. Or as I mean, occasionally, it also almost feels like stalk the rate at some point, since you're being stalked with this all the time during a meeting. Feedback is crucial. The PC, the working group chairs, everyone who's trying to put content on this stage likes to know if they're doing a good job. And your feedback to them is essential, no matter how you do that, whether you shout something in the hallway or fill in a form or whatever. Feedback is crucial, but here's our problem. The secret working group kind of doesn't exist, which makes collecting feedback a bit of a challenge. So here is my invitation to you. Please rate the talks, including this one, and I promise you, this is not a Rickroll this time.
Like, really? Phones out. Phones out. Phones out.
I would very much appreciate.
Approved, say, no joke, like really.
Secret working group telling this is no joke.
Yeah, I mean, I'll leave the QR up at the end of the presentation again, but we really would like to hear your thoughts on what to do with this thing. And with that said, see you all in, what's this pronunciation? Embra. But check which Embra you're going to book a ticket to. This is Embra of the Seven Seas, which is in the lovely Tristan da Cunha in the South Atlantic. If you're expecting to see a RIPE meeting there, you're probably going to get disappointed. So with all of that, thank you all for your time, and see you next one.